Today, Andreas, Jaeger, and myself, Stefan Behlert, both from the product management for the SUSE Linux Enterprise products, will give you an introduction how SUSE can help you to reduce planned and unplanned downtime caused by either failures or by maintenance updates. We will talk about where high availability can help you there, how to reduce the downtime to a minimum with live patching, and also have a glance then at the world of containers and how Kubernetes will impact you here. With that, Andreas, let's have a look at high availability and why it's important for your uptime strategy and an important building brick there.
Thank you, Stefan. Okay, high availability. Why are we doing that? We are doing that to protect against costly downtime. If you have a service that is running, a downtime of 5 minutes, a downtime of 5 hours will cost you a lot. So you need to protect against that. And what can happen? So what happen can be a software failure or system failure, or it can be a hardware failure. The other question is what do we protect against? We can protect the server and all the data. And protecting the data is something on the external storage, but still, if you protect the data and have that highly available, you still need to have services running to access it. And keep in mind, while we're talking about high availability, it's all those technologies we're talking about are often used also to handle large loads. Because a side effect of setting up large loads on multiple systems is also making it resilient and highly available. So downtime, why can it happen? There are unplanned changes like system failures, natural disasters, a drug running into our data center, power loss, flooding, whatever. Human error can also happen. We all make mistakes, and that can also result in a downtime. Malicious attacks is another area that happens. But besides those unplanned changes, there are also planned changes. It might be updating software or updating hardware, either a piece of it or the complete hardware. It might be migrating data to a new storage infrastructure, performing system maintenance, patching, just some configuration changes, or doing some tests and evaluations on your system. All that can result in a downtime, which will result in your service not available and your customers, the users of that service, not happy because they can't work, they can't play, or whatever they're using your service for. We are talking about zero downtime. We have to look at three things. On the one hand, we're looking at high availability. The other side is what Stefan will talk about is live patching, but also security lifecycle to keep your system secure. And then we have monitoring configuration checks. We're not talking about monitoring. We're not talking about how your system works, but having a system that is monitored will show you when you have a downtime, and it might give you also an advance when something is happening. And checking your configurations will ensure that your system is running smoothly. One way of handling high availability is redundant hardware. The set systems, the IBM set systems, are one way of doing it. Everything is redundant here. They have CPUs with double paths, etc. So that's one way. But still, somebody could cut the power in your data center and your nice set system is down. So you need to protect against that. Another way of redundant hardware are storage arrays. Storage system that have redundancy built in. Still, you are serving the data from an application that you need to protect against, and the same is happening. What are you doing if your one data center is down? There you have the storage area. How do you are protecting that? We're not talking about storage, we're looking more on the system side today here. And for that, a couple of concepts that are important in the high available. On the one side, we're talking about active. You can set up multiple systems. So we have here on the right, we have 3 systems, and all of those can be active at the same time and serve the data. That's an active setup. Where you can where your users can access the service via a balancer, and it gets distributed to the 3 systems, and it's always available. If one node is down, the load balancer get notified and redirected to the other 2. Active passive means that you have, let's say, you have 2 systems. One system is running, the other one is in standby, and all the way your users are connecting to that single system. And in case of a downtime, in case of patching, you redirect it either manually or via automatically to the standby node, brings it up, and have that one running, becoming active, and do the maintenance, do the work on the previously active node. What to avoid here especially is that you have multiple nodes that all think they're the only node. So if we are in an especially an active passive node way, the passive node normally is not doing anything, but the active node is writing to the database, etc. But if both nodes are thinking they are active, they would write both to the database or wherever you store your data, and might corrupt it. So ensuring that you don't have here a split brain where where you have multiple nodes thinking they are the master, they are responsible for they are the active nodes in that setup, is important. And for that, a concept here is called fencing, where when you take down a node, you cut down the access to the data as well, or in a failover state, in an active state, you might even shut down the node completely, so that nothing can happen and it can't do anything. And for that, we have that we talk about Stonus technology. Shoot the other node in the head. That's what's happening here, and our high available scripts can do that and take care of that. If a node causes any problems in an active passive setup, especially that the previously active nodes get stopped properly, get shut down, and can't access the data anymore. And the previously passive node, which is now the active one, is controlling everything and serving the data. For this one, you need a couple of tools of the trade software. Here on the Linux world with SUSE Linux Enterprise, we are using the pacemaker stack. We have the pacemaker as a cluster resource manager. It's a brain of high availability. It knows all the resources. It knows how your systems are set up, how many you have, what it's using, and takes action based on loads. Whether it's manual intervention, makes this one the active node, or whether it figures out via keep alive device that the other node is down, and then moves the load to another one. All the messaging between the nodes and from pacemaker to the nodes is done via co-sync. Another part here, what we have is a Stonus device, a Stonus block device, often where several nodes are writing to it and shows that keep alive. And if that fails, you know that you have to shut it down. So very, very highly on an overview. We can't go in much details. What you can do here with a complex setup, you might have a scale out scenario. So a system where you, instead of having a single node, you have multiple nodes, multiple servers running to distribute the load. So have on each server side here, side A, B, and C, you have 2 nodes. For data recovery, you're having 2 main sites that you have easily and have a very remote site for the disaster recovery. And then you might do replication of data from site A to site B and also to site C, that you can do a quick failover from site A to site B in case of site A is down, or you want to take the cluster in site A down, move it for maintenance, it goes to site B. And if that could be on the same location in different different parts of a building or whatever. And if both are down, you switch over to the site C. That might take a little bit longer to do that. I might have a little bit of lag for syncing of data, but that's what you can do. That's what's important in a really complex scenario, and that's what admin's doing. That really need a service that is 24 times, 7 days a week online. So you can do all of that with the products that we have for high availability. We have our SUSE Linux Enterprise High Availability Extension, which is an extension on top of SUSE Linux Enterprise Server. And one of our key workloads that we have are SAP applications, and we have integrated those high availability extension into that, and also integrated all the settings, the working of SAP workloads, especially of SAP HANA and NetWeaver, with our products to support that and to allow complex scenarios. Another way of avoiding downtime instead of having a high available setup is something Stefan will talk about now with live patching.
Thanks, Andreas. Sometimes recovery and backup systems for business critical applications are not enough. Mission critical applications need to be up and running constantly. And as you can see on the next slide, a downtime of such an application for a few seconds or even a few minutes in worst cases cause significant costs and has often significant business operations impact for the whole business and the whole companies. And these costs can go very, very fast into the millions. So a mission critical application is often very demanding on the hardware as well as on the software where it's running on. And to avoid the downtime is something that is essential for businesses. Restarting and getting back to full operation mode of such an application is time consuming. So it takes a lot of time until the system is fully running. Compromises have to be made there between patching the system with critical vulnerabilities and the uptime of the workload, which leads to a very simple idea, the one of live patching, fixing issues without disrupting the workloads that are running. But live patching comes at a cost. It impacts the system as the patches hook into the running code. The efforts required to do this without interrupting, or in worst case, blocking or crashing the to-be patched system, lead to the conclusion that not at all places it makes sense to do a live patch, or in all situations. Let's have a look here at the 3 areas which can be identified. The kernel, of course, is the most critical one. An issue here, well, it affects everything. If you have to patch it in the traditional way, a reboot of the whole system is unavoidable. Next comes to mind are the applications, be it from third party, be it homegrown applications that you are running. If there's a serious vulnerability, you want it to be fixed, resulting in a downtime of that application and, of course, of depending ones. Not necessarily on the whole system, but at least it could affect the wide ecosystem if you have to shut down your application. But there's also a third category that's sometimes forgotten, which are the shared libraries. Those, think about, for example, on the glibc, have an impact not on only one application, but on several. So if you patch something here, then it affects not just one application, but a bigger system, maybe the whole system. And moreover, if there's a critical vulnerability in one of these libraries, it also affects not just one single application. So let's look at the impact on these three areas and the cost and problems connected with it. If you look closely, you find out that there are two main areas where live patching is reasonable. First, the kernel, and second, the shared libraries. Both have system-wide impact when it comes to avoiding downtime of workloads and therefore the biggest value. So, as you see, the kernel live patching is state of the art. SUSE security team reviews all the fixes that are available, and if they are applicable for a live patch, you get the live patch and can have it on your system installed. More than 2,000 live patches have meanwhile been issued for fixes and provide an increased uptime on customer systems. Creating a live patch is not easy and it's costly, both on the creation side as well as on the implementation side on the running system. So we have a threshold here that is applied, and not every single vulnerability, as small as it might be, will see a live patch, but you see the criteria for it here on that page. This has also the advantage that it reduces or prevents a complexity on the running system if several live patches are installed over the time. And with kernel live patching being applied, we have seen some cases where a system had not to be rebooted for a year, which is quite an amazing time frame to run without vulnerabilities. But aren't there also issues beyond the kernel that are forced to cause a disruption on the system and the workloads? You remember? We mentioned the shared libraries. So, as we said at the beginning, having an up and running system is one part of the problem. Security incidents happen in basic libraries, requiring a restart of the applications, and the mission-critical environment is time-wise for reboot as bad as the whole system. But while the kernel is a familiar territory with well-defined structures, in user land, you have a variety of structures, libraries, a complexity that is way beyond what you see on the kernel side. This makes live patching in the user space much more problematic. And throughout and thorough research from us showed that there are some issues involved with that. Nevertheless, with Service Pack 4, we are proud to provide libpulp, which allows to apply live patches in selected shared libraries. The libraries we are targeting first are the glibc as well as libssl, as both of them have system-wide implications. Why only two? Because the libraries need preparation. You cannot do live patching on an unprepared library. That has to be said in all fairness. And those two are the ones with the biggest impact on operation. And therefore, we start with those two. User space live patching is part of the live patching extension. And as we said, we are proud to offer it as the first enterprise distribution to our customers. We are happy to hear which further libraries you're interested in seeing next. We will enhance the number of libraries over the coming months and years, but we started with those two. But with that, let's go to a different topic, the containers. Andreas.
Let's look at Kubernetes. Kubernetes is a management framework for container, and it has built-in high availability for container workloads. It is built on the concept that you can run multiple containers in an active way the main way of doing it. You can do active passive as well, but active is what is normally done, and easily use have multiple workloads running at the same time, multiple processes running at the same time, easily scale them out if your load increases as well, or scale them down, and also easily patch those containers. The nice thing about patching with Kubernetes is that you can it has built-in concept. You're not patching a container. You're just throwing away the container and starting it from scratch, starting a new version. With Kubernetes, you have the option of, in an active setup, let's say you have 3 containers running, 3 processes running for your workload, with a load balancer in front of it and external storage behind it. You can start, instead of patching a container, you start a fourth container, and then kill one of those three running ones. Then it starts the second new container and kills one again. And the whole time your workload, you have at least three containers running, 3 processes running for your workload, while updating it. It's a complete different way of handling patching a system, but that's is something that Kubernetes is built in, and even has a built-in that allows you to do that update here, this way, automatically without user intervention. You just say update to the next version, and it goes from one, starts a container, stops one, stops one, etc. So built-in high availability for container workloads. Kubernetes also monitors the workloads. So it checks that each process is running, that is, that they're live. And if it fails to get a liveness signal from a container, from a process, it will kill that and start it somewhere else, for example. Or if a node is down, it will figure out the node with my 20 containers is down. I need to start them somewhere else, and we'll start them somewhere else. So that way, Kubernetes itself is taking care of all the high availability here for those workloads. For that, you need to set up Kubernetes for sure with no single point of failure, so that Kubernetes itself is highly available, which can be done. And then you can also schedule your workloads with constraints across multiple nodes, like not all of your processes running on the same node, or even over multiple availability zones. And yeah, there's an API as well for managing replication, for managing multiple nodes here as well. So that's important as well. So Kubernetes, if you have an active setup, your application is ready for that. Nothing to do. It's built into Kubernetes. High availability is built into Kubernetes. The question is what to do with and this one, the active setup of often stateless applications. The concept you're using here is deployment, and on the right you see the snippets for the configuration file. You have your deployments and just say replica 3, so it will ensure always three versions of it are running. You can connect an ingress or a load balancer as well for load balancer and integration, and Kubernetes will take care of that the traffic gets routed to your containers the right way. For stateful applications that store data and are dependent on that data, you need highly available remote storage. But you also can enhance Kubernetes for complex setups where you have an active passive setup where one node needs to know that it's passive and get data, and that might be in a SAP HANA or in PostgreSQL setup where you have one primary and several standby nodes that need to sync with each other and therefore need to talk with each other. That can be done, but that's not built into Kubernetes. That needs extra work that is needed for that one. And with that, I hand it back again to Stefan.
Thanks, Andreas. Constant uptime and availability does not come out of the blue. But you need to carefully plan your systems and your setups And SUSE, with its variety of solutions, can help you to reduce the downtime to a minimum, be it due to failures, be it due to planned maintenance updates. We spoke in that session about how Kubernetes can help you with its built-in mechanisms. You've heard about the high availability extension and how it helps you to cover for failures. And you've heard how with the live patching extensions, the unexpected downtimes are becoming an endangered species. Whatever you choose as a setup and as products, setting up the mechanisms that brings you the availability and the uptime up to months or even a year requires some efforts. And to ease this, we have also several more detailed sessions here at the SUSECON, and you can find them here on the slide. The presentation is also downloadable, so you can click on that and then get to the session that you're interested in. We wish you now always running systems and workloads and a nice SUSECON. And with that, thanks for listening and have a nice SUSECON. Thank you very much.